All right, let's move on to questions 4 and 5. And what we have is a matrix A, and it says find A inverse. Now there are two ways to do this. You could find it by augmenting the matrix and doing row reduction. But for the 2 by 2 matrix, you should know the formula. And the formula tells you that to get the inverse, you switch the diagonal elements, minus 2 and 1. You negate the off-diagonal elements, minus 2 and minus 3. And you divide by what's called the determinant, which is the product of the diagonal elements minus the product of the off-diagonal elements. Now this formula only works for a 2 by 2, but you should know this formula. So it's going to be minus 2 minus 6. So it's minus 2 minus 6. So that gives me the result. And if I simplify, because that's 8, so minus 8, I'm going to get 1/4 here. And then I'm going to get a 1/4 here. And then I'll get a 3/8 here. And I'll get a minus 1/8 here. Okay. So that's my answer for my first guy. Now it says use this result to solve this equation, AV equals W. Now what is AV equals W? It's just another way of writing the linear system. What I hope that people would see, and maybe people didn't catch this in the web work homework, is that if you take AV equals W, you can transform this. One way of thinking about it is multiplying on the left by A inverse here and A inverse here. And that's the same thing as saying that V equals A inverse W. Okay. Now, since I know what W is and I know what A inverse is, I can use that to solve it. So that means that XY is equal to, now what's my A inverse? It's going to be just 1/4, 1/4, 3/8, and minus 1/8. And that's times W, which is 5 minus 1. So I'm not going to work that out, but that's how you do it. Let me refer you to the place in the text that talks about this. Here it's at the beginning of matrix inverses and systems of linear equations. And it's this example, SABMI. And so you need to, when you read through the text, you have to click on all of the expanding things to make sure you get every example. So look at this example, and this is just what we're talking about. System of linear equations, and they represent it in this way. And then he says, take this matrix B, which happens to be the matrix inverse, and multiply it by A, and then you get X equals BB here. So X is equal to the matrix inverse times the vector B. So that's what he's doing, and that's what we do to use the matrix inverse to solve the system of linear equations. So let's look at question 5. Question 5 says, given A inverse and B inverse, solve the equation ABX equals B. Now, you think that this is the same type of problem, that you're just using a matrix inverse to solve the equation. There's one wrinkle, however. ABX equals B. Now, if I use this same idea to try to get rid of the A and B on this side, notice that if I multiply by B inverse here, it's not going to work. One thing that people had trouble with was if you multiply on the left over here, you have to multiply on the left over here. I saw a number of people multiplying on the right over here, which is not possible. Right, so the B inverse is not going to work there. I have to multiply by A inverse. Okay. If I multiply by A inverse, this becomes the identity. Now if I multiply by A inverse on this side, I need to multiply by A inverse on this side also. Now if that becomes the identity, then what's in front in this equation is the B. So I multiply here by B inverse, and I get B inverse here. So here I also have the identity. So what that tells me is on the left-hand side I have X, on the right-hand side I have B inverse A inverse times B. All right? So all I needed to do to solve this problem is take the vector B, which was 1, 1, 1, and then multiply first by A inverse, which is this one, 1 minus 2, 0, 3, 0, 4, 0, 1 minus 1, and then by the matrix B inverse, which is here. 0, 2 minus 1, 3 minus 2, 2, minus 1, 0, 1. Now let me show you where it talks about this in the text. All of this was in this same chapter of matrix inverses and systems of linear equations. If you go down here, go down a little bit, and by the way, here's the formula for 2 by 2 inverse, which you should remember because it's an important formula. They have that in the teacher certification exam. And down here, down here, down here, it says, if I have two matrices and I want to get the inverse of the product, it's the product of the two matrices backwards. So that's why we multiply B inverse times A inverse instead of A inverse times B inverse. All right, so that's how this solution comes about. And I won't do the multiplication, but that's how you would get the answer.